right. Well, welcome to Construction Tech. My name is Kevin Brennan, reporting live from New York City here. Great new video, great new season of Construction Tech. I know Norm and the team and Gary are gonna bring the technique, the technology, and the I forgot the last T. I'm on the spot here. Anyway, the technique, the technology, and what's the last one I'm forgetting? I'm getting old.
Technical technique.
Technical. So technically, this is one of the more complex renovation projects I have seen. I feel like I've been through COVID closely connected to the project because it's been such an element and following along the story. We made connections with Norm and Gary while we were all locked up during the COVID process, and following the project along and then hearing the results. It's truly a hero story of taking what seems to be an unsurmountable project and goals, and then going through construction, problem solving, and getting through and hearing their results and where they're at. I'm excited to see this show again. Thank you guys for joining us, and hopefully I have my brain back for questions. Thanks, guys.
All right, so Kevin Brennan laying down the technical technique and the technology. I'm Mark Willey. Get ready. This is a 4.5-hour presentation. I expect everyone to take lots of notes. After it's over, then you could watch the 7-hour part 1, and that will show up in the chat. Please don't believe me, but do believe everything you hear from Gary and Norm. Throughout the first episode of Accelerator to now, you'll see little updates of what they're doing if you're involved in those after hours conversations. They're very small windows on this building, and not a lot of Proseco was used, but it was phenomenal. I'm exaggerating to the minimal. Every detail on this inside and out is extraordinary and specifically designed, and the craftsmanship delivered. It's also a beautiful space. So when you hear comments from Gary and Norm, and when you see photos, if technical, if technique, and if technology shows up for you, put that in the chat so we know what lands for you. And Sean, you're on the spot, pink shirt.
Well, thanks, Mark. I think you were bringing a fourth T today. You were bringing some teasing to both Norm and Gary, but of course, you're always bringing the fun, which we appreciate. So for those who don't know me, I'm Sean Sainamore, and maybe your school kids might be wearing a pink shirt today because it's Anti-Bully Day, definitely being represented out here in Canada. I'm in North Vancouver, where the local mountains got some snow last night, and so it's nice that we're talking about comfortable, healthy buildings, and not just residential buildings, which seems to be the main thing we talk about. Today, we're going to talk about the commercial aspect. And so Passive House is applied for all buildings. And today we will, again, as Mark said, we're getting part 2. So hopefully you did your homework or you've been to part 1, because now we're going to look into the results and some of the great aspects of how the project went around. So Shannon, I will let you introduce these 2 amazing individuals. Good to have you and the co-hosts and all of you here today. Enjoy the show.
Thanks, Kim and Kevin, Mark, and Sean. Welcome, friendly faces and future climate leaders, to this week's Passive House Accelerator Live Construction Tech episode. I'm Shannon Pendleton, and I lead Passive House projects at Sanderson Sustainable Design. And I'm grateful to introduce today's project and invite you to share the work you're doing to make our buildings more excellent and efficient. So today, Gary Moshier of Moshier Studios joins us as the designer and project manager. He's a Carnegie Mellon alum, a co-founder of the Green Building Alliance, a LEED accredited professional, and a leader in the green building movement in Pittsburgh for over a decade. He consults with architects, contractors, developers, and owners, and has extensive experience creating high-performance spaces for customer contact centers throughout North America and internationally. So along with him, you're going to get to hear from Norm Horn, they've both been longtime Passive House Accelerator friends. But if you don't know Norm, he joins us today as the construction project manager, bringing over 20 years of experience managing residential, light commercial, new construction, and retrofits. He's a Penn State alum, and he does building envelope and energy efficiency technical assistance for builders, design professionals, and owners at all stages. So prior to New Ecology, Norm worked at Invinity in State College, where he was heavily involved in this project in both the planning and field activities. And I want you to join me in welcoming both of them and all of Team Six&Kane, because it looks like we've got a lot of folks that were part of this big team that made this amazing project happen, joining us today. So put your questions in the chat, and without that, I'll take it to Gary and Norm to share their screens.
It's great to be back here on the Accelerator for Construction Tech. Still getting used to the daytime thing. So as Shannon said, my name is Norm Horn. I'm here today with Gary Moshier, and we're going to talk about a project that we worked on together over the last few years called Six&Kane. We did an in-progress presentation about this building here in September of 2021, back when Construction Tech was on every Tuesday night. And so it really means a lot for me to be back here to talk about this project. It's one that I'm incredibly proud of. And, you know, at the time that we were building it, I was traveling for work to do this job and almost literally living at the job site. And, you know, all the while trying to navigate, you know, disruptions of COVID and pandemic life, and having the Accelerator as that social anchor 2 nights a week during those times, it was a real lifesaver for me. So it means a lot to be back. So we're going to share some more details about Six&Kane today, some new stuff, some expanded discussion from the last time. I'll provide a little bit of context here. Start out with a quick overview of the project program and what our individual roles were. And then, you know, since there's so many things that we could talk about in this building, we really don't have time to get into all of them today. We're going to take a close look at 2 of the building assemblies and talk about the design considerations that went into them and what it took to implement those moves in the field. And then Gary's going to finish up with a little bit about what we know about how they're performing and how the certification is coming together. So the property at 63 North Fraley Street in Kane, Pennsylvania, down here in its before state, is an EnerPHit renovation of a 3-story mid-block masonry building built in 1897 and then added to sometime around 1918 or 1920. Gary will get into more detail about the specifics of that certification, the EnerPHit certification later. So over its life, the building had been a dry goods store, home to the Kane Moose Lodge, and most recently a bar before it sat vacant for several years. And it was purchased in 2019 by the West Penn Power Sustainable Energy Fund, which is a nonprofit organization that provides investment capital and grants to spur the deployment of renewable energy and energy efficiency measures in Western and Central Pennsylvania. So after 20 years of providing funding and assistance centered on techniques and technologies, they began to focus their efforts on economic development, education, and environmental betterment through the lens of sustainable energy. So for a quick geography lesson, for those of you who don't know, Kane is a town of about 3,600 people, located in Northwest Pennsylvania, just below the PA-New York state line. So about 120 miles north of Pittsburgh, 110 south of Buffalo, 90 east of Erie, and about 2 hours west of where I lived while this project was happening. Kane's right in the middle of the Allegheny National Forest, where the regional economy is primarily driven by logging and timber production, along with tourism and outdoor recreation. And the building's name, Six&Kane, comes from the project being located on historic US Route 6, which cuts across the northern tier of Pennsylvania as it connects Massachusetts to California. So after the fund purchased the building in the summer of 2019, they started a lengthy gut demo and clean out project and engaged the firm that I was working for at the time, Invinity, from State College, Pennsylvania, to do some early stage energy modeling and explorations of how far we may be able to take a building like this in terms of performance. And InScale Architects is a local firm from Warren, Pennsylvania, was looking at the existing conditions in the structure. Then in October of 2019, the fund's board voted to pursue the PHI EnerPHit certification for the renovation, is when Gary's firm, Moshier Studio from Pittsburgh, was brought on to be the lead architect and passive house consultant. Invinity and I stayed on as the construction manager, and InScale stayed on as the associate architect. So between the summer of 2019 and the fall of 2022, Six&Kane went from a vacant shell of a building, really an active decline, to a community connector that's now home to both new and established local businesses, the local Chamber of Commerce, and it serves as a hub for education and economic development in a rural area. On the technical end, there's really no shortage of things that we could discuss today, but given the time, again, we're going to take a closer look at two assemblies, the front facade and the rear elevations. Talk about what we started with, the opportunities and limitations that Gary worked through in the design, and how those moves got implemented in the field. And then we'll wrap up again with what we know about how the building's been performing since it was occupied back in October. Well, I'll turn it over to Gary now to discuss the existing conditions for each and how he approached it from the architect and passive house consultant perspective.
Sure. Thanks, Norm. Go to the next slide, I think. Yeah, so existing conditions in the context. As you can see here, Kane is a 2 to 3 story context, mostly brick. It's all local brick. There's a brick plant not far from here. Actually, there were probably several back in the day, and local timber. So when we got into this building, there had been a masonry restoration expert look at it, and they basically recommended that the front wall be removed because it was basically going to come down sooner or later. Anyhow, it was on its it was really living on borrowed time. So that was a given that the front facade had to be replaced, and so that was kind of our starting point. Next slide. Yeah, more of the context. You can see there's some various stages of repair, disrepair, restoration all around us. Some stuff's been really well cared for. Other things have kind of been let go. Some things have been actively made ugly. So we had a lot to deal with in the context. Next. We had a few precedents that we looked at, looking at how do we deal with getting light into the building, how do we deal with the various masonry and stone contexts. We had masonry building on one side, stone building on the other, or brick masonry on one side, stone on the other. Being a long, narrow mid-block, we wanted to get windows and to let the light in. Next slide, please. And we came up with a couple different sketches that we were tossing around, looking at masonry, looking at stone, just sort of how do we accentuate and work with the organization of the plan. We knew we wanted to organize all the circulation along one side of the plan, so we sort of went to the quickly migrated to the more asymmetrical appearance on the facade. Next. Sort of landed on one option here where it was timber curtain wall. We kind of knew we wanted to do that, even though it was not local. We wanted to have that sort of pay homage to the local wood economy. Looking at doing clad wood windows and possibly a slate facade, sort of lightweight. Go on, we had some other options we looked at. And just various amounts of glass. Basically, we just wanted more and more glass on the front as much as we could, and then exploring different options. So we kind of landed on this one where we ended up with these larger curtain wall elements to let the light into the front of the building. And the other thing that happened here is our client is a geologist, and so he wanted stone. We also had the really nice sort of Sullivan-esque stone bank building next door, and we knew we wanted to pay homage to that. We had a source for good local stone about an hour and a half away, and so we kind of went with the stone and then tried to figure out how to make that happen in a thermally broken clip system. So talk a little bit more about that. I've got some sketches of that later. So Norm, next. So our front wall section, we have a steel structural steel tube system that goes up here in the middle. I don't know whether you can see my cursor or not. Probably not. And yeah, so we've got structural steel tube going up the middle. And then in front of that, we've got a weather barrier, which we use the zip R sheathing on the front side as a weather barrier. We also use the zip R sheathing on the back side as our air barrier. You can see the red line and the blue and the green line there. And then in front of that assembly, we put in 8 inches of insulation. Originally, we wanted to use the rock wool, but we just couldn't get it. But when it came time to build it, we have the rock wool inside of the stud walls on the inside, but we ended up having to go to a Neopor GPS on the outside in the end. So that's our basic front wall sandwich. Next slide. And one thing we did is, if you look on the left, we had original window detail. I was looking at using window units and kind of building it out with some structural foam and some aluminum cowlings and sort of building it up this way. When we went out to the curtain wall, we were looking at the Rayco curtain wall distributed by Tanner. And Stefan came back and said, I can do these other windows in the curtain wall. And not only that, I can simplify the whole thing. Just, we can make this curtain wall frame element as deep as you want. So we came up with this like almost 20-inch deep curtain wall surround frame and just attached our curtain wall to it. And it really simplified things. It simplified the air sealing, simplified the thermal bridge, and gave us a really cool look on the inside with lots of wood. So we have some photos of that later. So that was a really great example of how just, collaboration with the suppliers and other folks on the team really improved the project. Then on the back side, we had our existing 3-wythe masonry, which was all pretty sound. It needed to be pointed inside and out just to give us a good surface to air seal. But on the inside, we used the Viscon air barrier and that allowed us to keep the brick exposed in a lot of places. On the outside, we used the Prosoco weather barrier. We used the eco cladding alpha clips. Should have used the Sigma. Used the alpha, sort of a rookie mistake here. This is, by the way, our first passive house building, so we kind of jumped in with both feet. And we made a few mistakes along the way, but nothing fatal. So, and then we came up with this idea of building out the window buck using the Armatherm structural foam to get the window out into the insulation layer and also wrap a good layer of insulation across the front of the window frame. So in the end, we actually ended up with a negative psi value on our window install, negative psi install, which is kind of fun. Apparently that doesn't happen much. We're working with Tad at Certifier Consultants, and he hadn't seen a negative psi value before, but Matt, one of his partners, had. So he said, yeah, it's a thing. So here we are. So anyhow, that's the back. We added the insulation on the outside, and then just a metal siding solution on both vertical and horizontal metal siding, red metal siding on the exterior. Again, we had called out rock wool, but ended up using the Neopor. So next. And here's the head and sill details. So just all kind of making it all work to get that good thermal break around the window install. Next. So here's the front of the building. Is this where you take over again, Norm?
Yeah, I can take over again if you want.
Okay.
Okay, so we're back to the front. As Gary noted, there was really, no architectural or historic value to the facade when we started, and it was in quite poor shape structurally, along with the tiny window openings. So it really presented an opportunity, to make performance gains as well as an architectural statement. The existing structure came down pretty quickly. And we stabilized the floors and got it ready for the steel fabricators to take their final field measurements to start welding.
I should note too, on that temporary wall that you see, the zip sheathing, that actually
Yep.
became our floor element on the first floor and became our first floor air barrier to the basement. So we didn't waste any of our construction materials.
So we were really fortunate to have a capable steel fabricator about a half an hour away from the job site who took care of all the structural steel, as well as doing the stairs, rails, entry canopy, and decorative metal work. So they fabricated the steel frame in two 57-foot tall towers that made up the outside bays of the building, and then just a simple bolt connection up the middle to connect the two. So then once they got the steel set and secured back to the existing structure, we get started with infill framing and sheathing, which really started to give some definition to the openings and started to show what the building would eventually look like. And it's worth noting here too, that while that steel was being fabricated, we also removed and replaced the entire roof structure of the building so that we could locate all of our insulation outboard and provide an adequate structure for the ballasted PV array that now covers the roof. So then after we finished the sheathing, it stayed wrapped up like this for quite a while. So an important part of the story here is that because the start date had gotten pushed back with the COVID shutdown, Gary's process was thoroughly interrupted while he was developing documents with that one. All this work, facade and roof demo, the steel fab and set, the new roof framing, insulation, membrane, all of that took place in the space of a little over a month. And it really took all of our attention to make it happen before fall turned into winter, because we needed to get this done before we had an open building in the winter, back when we actually had snow. So a lot of the owner's decisions also got pushed back, as did their interactions with Gary to translate those decisions into a design. So we took the next few months to really refine the details of the assembly, as well as addressing all the other stuff in the building, like the interior structural work, adding an elevator, making connection to the neighboring building, coordinating the PV system, interior air sealing, mechanicals, and given the passage of time, a certain amount of adjustment to the interiors as tenants and uses started to take shape. So the three main components that we had to coordinate for the facade were the timber curtain wall shown on the left, the insulation and thermally broken clip and rail system, and the stone cladding that hangs off of that system. And we really couldn't have asked for a much better experience with getting the Ryco timber curtain wall coordinated, shipped, and installed. Gary worked extensively with Stefan Tanner to get the right system components selected and detailed to optimize the thermal conditions and to simplify the installation and water management. And then, Stefan's sons handled the import, logistics, and installation of the system. In fact, Stefan, along with his sons Seth and Ollie, shown here, pulled into town within an hour of the container arriving and started to unload and assemble things immediately. Here we have the container and Ollie banging some of these big, deep pieces of glue lam timber together. So, getting everything correct at this stage was really critical for the success of all the following steps. As all the curtain wall components needed to be in plane with one another to allow the stone cladding to plane out with neighboring buildings and intersect with the glazing as Gary had intended. So these are 9-foot square triple pane openings here. I think these two provide a lot more glazing than what was in the original facade in total. And like Gary mentioned, air control layer here is happening at an interior layer of zip that was reused from the shoring and then taped to the steel and to the backside of the glue lamps. One of my favorite parts about how this system came together is that we have these 19-inch deep pieces of timber that really express the full thickness of the assembly very cleanly, elegantly, and there's no sight line, no window frame to narrow that view down out over the town. So as with much of what we did on the front of the building, space is at a premium. And I recognize that this is probably nothing compared to what some of you have to deal with when you're working in cities, but this is a pretty big deal for a small town. And the guys were able to set most of this glass off the telehandler. Most of the larger pieces, though, needed a crane to reach up there to be able to maneuver these pieces. And this is actually the outside of those two that I showed earlier. And then, speaking to the difference between working in a small town and a city, we really benefited from the more relaxed approach that the local authorities had to closing down a travel lane of a main road. We had to move glass racks out onto the street basically every day, 2.5 tons of triple pane IGUs sitting out there with the log trucks. So, something that we talk frequently about here on Construction Tech is the value of doing mock-ups. And we got a lot of mileage out of this little one that we did for the facade, both as a tool for helping us to do a better job of installation and refining our approaches before doing the real thing, but also as an education and outreach tool in talking with the community visitors about how we were putting this building together and why. So this image shows with the inside face, how it's stacked up. And then here's how the outside of the assembly started to go together. And there with a few of the stone pieces installed. So we'll come back to this a little bit. So with all the glass set, the carpenters moved into the insulation and the clip and rail system. So again, this is happening back in the fall of 21. So the situation with ships getting into ports was getting really bad. Materials in general were unpredictable. And like Gary mentioned, the original spec for rock wool and the facade just wasn't going to happen because they were so far out. And the rock wool that we had on site was not enough to do this part of the job. So we made some changes and switched it up to Neopore EPS, which is really where the mock-up was critical in helping everyone think through how the pieces would need to be cut or go in a sequence, since dealing with 2 and 3 inch thick pieces of rigid foam isn't the same as working with a material like semi-rigid rock wool. Ultimately, I think it resulted in a really superior installation job because I might kind of biased here, but a crew of finished carpenters just isn't wired to do a sloppy job with anything, much less something that's kind of like wood. I mean, they even went so far as to follow a note on the backup system shop drawings showing an insulation fill on the vertical girts, even if it didn't do a whole lot thermally.
Yeah, Ted got a chuckle out of that when he saw it. Yeah.
So here we are with a full 8-inch thick layer of Neopore and all the subframing set and ready for the masons to start setting their stone. And it was about this time, I was probably coming into about Christmas of 21, that everyone started to notice that it never really got cold in the building, even when it had been in the single digits overnight, like it was when I took this photo. And we had a single 15 kW electric heater inside that started to only come on like every other day for just a little bit. So all the work that went into air sealing and insulating really started to show some benefits at a very early stage. The last component then is the sandstone panels that were quarried a little over an hour away from the site. And while using that material is really nothing new for this crew of masons, installing it with a mechanically attached system instead of on a full mortar bed with ties was very new to them. So again, the mock-up played a solid role in helping to translate several sets of shop drawings from various systems and vendors into actually getting this thing done.
You can see the weather wasn't real conducive to brick and to a mortar set masonry anyhow. So we really lucked out timing.
Yeah, I don't think these guys had a day that was much above freezing the whole time that they were out there putting this up. Once they got the hang of it, though, it actually went pretty quickly. When each panel was even coded to its location and all the joints were coordinated during the shop drawings, to minimize the amount of cutting that they had to do on site to get everything to lay up and line out. So then this is my last official day on site before I changed jobs. They set the final stones up at the top. And then another crew came back later in the season and installed sanded caulking instead of mortar in all the joints to allow for some movement in this mechanically attached system. So I'm going to switch gears here in the rear elevations to wrap up my section. Unlike the front, we had to take these walls for what they were, warts and all. There were plenty of warts, hundreds of random fasteners. There were windows that had been abandoned, windows that had been added. I think there was even a 2-story covered porch and a staircase on the back here early on. And there were a lot of obstacles, like neighboring buildings that were 9 inches away from ours when the optimal plan would have really been for our building to grow by about 10 inches. So Gary had to do some edits to the PHPP, and we did some edits in the field to thin down sections of insulation and offset that with insulation inside. We also had a bank of transformers out here that we had moved to open up a safe space for lifts to operate against the building, and then moved it a bit more when they built a new 3-phase service, because obviously we went to an all-electric building here and got rid of the gas lines. So here's a representative window opening. Gary showed the detail earlier here. That's what we started with, pretty standard fare for a 3-wythe brick wall. And then here we started to fit out some of the Armatherm bucks that he designed. But before we could really do anything with those, we had quite a bit of repointing, more reconfiguring of openings, and applying the Presco R-Guard WRB system for the backup on these walls. You can see here, if you look closely, after cutting back the outer wythe of brick to true up the sides, the masons parged the inside of the openings, and then we coated that inside of the opening with Viscon, which is what we used on the inside for the air barrier, so we could leave the brick exposed and then paint over it. And then we stopped the Prosico on that outside corner so that we didn't have any compatibility issues between the two systems. And then finally, with all the bucks in place and detailing them to be continuous with the Presco materials on the walls. And then plugging the windows in was actually a pretty simple deal, because they just pushed right up against that stop on the front of the Armatherm buck. And then finally, ready for cladding. And I mentioned too, we talked a little bit about materials and where things were coming from. These are US made UPVC tilt turns from Ventana, made just outside of Pittsburgh. So while we had to go overseas for some things, we worked as hard as we could to stay as regional as we could with things like these windows and the stone and the local timber that went into interior trim and floors. So on the inside, it's a fairly simple task to clean up the brick dust, to get a good substrate to clean and tape to, and taping up all the corners, mounting scraps, screw heads, and the margin to the brick wall. And then finally added some deep MDO extension jambs painted in to match the walls, and some maple sills that carried on with the rest of the interior trim and doors. So again, like with the front, we had planned for the insulation to be rock wool. Wasn't going to happen. So we switched to Neopor, which also, I mean, it's not really a local material, but it came from a regional source about an hour away in Clarion, Pennsylvania. And here you can see how much more dense the backup system here is in comparison to the relatively few connection points that we had on the system out front, which I thought was kind of interesting. For holding up, the difference between holding up metal and holding up stone. And to the challenges back here, this is a picture that was taken the next day. Again, back when it used to snow during winter. But it did melt, and this one they've finished up most of the cladding. They're getting ready to start on a section of wall. You can see on the far left there where we had to thin the section down a little bit to avoid having to move or modify the neighbor's fire escape. And again, I really like how this came out. It's super clean, super simple. And with that one, I'm going to turn it back over to Gary to talk about how these things are performing.
Okay, we'll go to the next one. So here's a one of our team members, Rob Hoskin, who's a mostly a FIAS rater, I think, but he really does some phenomenal infrared photography. He's on excuse me, he's on the board of the excuse me, West Penn Power Sustainable Energy Fund. Is actually probably one of the people most instrumental in convincing them to do Passive House. But he took these really great infrared photos, and these were done on a cool October evening. Actually, it was the night before the open house for the grand opening. And you can really see the performance of the building, both the glass and the wall, compared to the neighboring buildings, with each just sort of coming out through. Next. And so these are just different weightings. I think the first one's what, rainbow spectrum, and this one's iron bow. Is that right, Norm? Or do I have them backwards?
Yeah, first one was rainbow. This one is iron bow.
So this is more
I know
similar.
Rob's here. We should pick on him to talk about the differences between those two when we get into questions.
Yeah, that lets you see different things in different temperature ranges. So it's really valuable to have. He gave us 5 different spectrums to look at, and it's really fun to see the differences. All of I should mention that all of these are going to be on our PHI certification website. It's all in part of the backup, and once we're certified, everybody will be able to go to PHI and download that information, or see it or download it if they want. So, and I have a complete explanation of all of them in the photo stack there. So next. Yeah, there's the backside. Again, the rainbow. You can see every one of those connectors. And then I think next we have the iron bow. So it's a little more normalized, less extreme. So yeah, so you can see it, compared to the adjacent buildings, it's really performing well thermally. Really everything's pretty much where we expected it to be. Next. Expectation wise, this is our FIAS or our PHI PHPP verification sheet. This was, I don't know, a bit ago. It's evolving. I'm working with Tad to try to get this turned in maybe this week, probably next week, maybe this week. We're down to the last couple items here, so we're still in the same range. So you can see our heating demand is 5.03 kBTUs per square foot per year. So we're actually just over the limit of the normal passive house, not EnerPHit, because the EnerPHit criteria is 9.51. So we're almost half of the EnerPHit criteria. The thing that's really helping us here a lot is if you look down here at air tightness, we're at 0.2 air changes per hour. We're allowed 1 under EnerPHit, but Norm and the whole crew up there just really hit it out of the ballpark as far as air tightness, and that number drives a lot of stuff. We're talking about levers to get results. Air tightness is like the biggest lever you have. So if you get the building nice and tight, everything else kind of falls into place. We are going to be going for EnerPHit Plus. So we're producing, well above the limit for our primary energy renewable. Our PER demand is right in range, and so we're right on track here for EnerPHit Plus. Yeah, just here's everybody on the team. It was a team effort, and really could not have done it without everybody pitching in. So I guess we can get into the questions now.
Fantastic presentation, Gary and Norm, and congratulations on hitting incredible blower doors, negative psi values, the first commercial EnerPHit building, and soon, I'm guessing, to be EnerPHit Plus. Amazing. And the process that you showed in photos, you gave a great presentation verbally, but you almost didn't need to say a thing, because that process, that workflow that you showed pictorially was exactly what construction tech is all about. So we thank you. We thank you so much for sharing this with all of us. We do have some questions to take us a little ways forward before we invite our sponsor, Real, and Sean to come back and give everybody a greeting. The first one I have to say is one of our favorite Passive House questions from Harvey. Do we still have Harvey? If not, I will jokingly ask it for him. We don't. Harvey must have had to leave. But Norm, Harvey says hi, and he says, how much does it cost?
I don't have a good answer for that right now.
Of course not. And for those of you who don't know, this is Harvey's running question for every project. So it is a bit of an inside joke. And forgive me for putting you on the spot, Norm. I just couldn't help myself.
That's okay.
Our next
I kind of
question
figured
up-
what it was going to be.
Yeah, our next question up is from Dale Rudiger.
Yes, I'm right here. I'm calling from Calgary, Canada, and I'm just wondering if there's a secondary plane of protection behind the stone facade.
Yeah, there's the, you may have noticed the Advantech or the zip sheathing. It's a brown colored sheathing that was taped. So that's basically an air weather barrier on the that's behind the foam. Yep.
So it's behind the foam, but not directly behind the
right. We have an air gap about a 2-inch air gap between the face of the foam and the back of the stone. So any bulk water that does get in there can find its way down in that chamber, and but we do have the air barrier.
And weep holes on the bottom, of course, right?
Yes.
So
yeah, it's all weeped out.
Perfect. Mm-hmm. It wasn't clear in the pictures, but I assume that it was.
Yeah, there's a lot to show.
Yeah.
Great. Next question up is from Sandra Lester. Now, Sandra, I know I answered your question in the chat, but did you have any additional questions about the product they used?
I just haven't seen that structural foam used in that detail. And I was really impressed at how far it brought the window outboard of where it usually sits in the wall. And I'm just wondering, whether that is becoming more standard and whether you had any challenges creating that detail.
I think I sort of came up with it. I'd seen the foam at couple of the conferences at the trade expos, and it struck me that being a structural foam, and I checked the shear capability of it, and it was fairly similar to plywood. So I know a lot of people do the plywood, jam extensions, plywood outies, and I figured, well, gee, why don't we try doing this in foam? So Norm went ahead and started looking into it, and we just didn't realize how expensive the foam sheets were. I think that's probably the biggest barrier is the cost. But I've been talking to, I understand Tad's working on a certification of another project where they're doing something similar. So it's it's not out of the question. We just sort of saw it as a interesting way to do it. We probably, if I go back and look at it, we could probably use some of the higher density kind of normal foams and not have to go to the Armatherm, but it was kind of an experimental thing here. So I'd say probably the biggest barrier is the cost.
Speaking to the lateral alignment of those windows, I mean, you can see in this photo on the right, so the window would butt up against this thin stop on the front. So it was really it wasn't even completely outside of the masonry structure. And we had a kind of a sill block support underneath. So it ended up well within the thermal mass of the wall once we got them installed, because we added so much insulation. So we added 8 inches of insulation onto that, which allowed it to set back then 4 inches.
Thanks, Norm. And thank you, Sandra. I know you had a follow-up question, but hang on to that for just a minute while we go over to Kim for sponsors.
Hi, I'd like to give a big thank you to the fine organizations that make our work at Passive House Accelerator possible. First, a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you too to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwool North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Icon Windows and Doors, Intelligent Membranes, Proseco, and Source 2050. And thank you to our patron sponsors, Aero Aggregates, Brennan, Brooklyn Solar Works, Euroline Windows, Coltraco Ultrasonics Micro Air Leak Detector, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you, sponsors.
I hope you guys enjoyed the sponsors. Again, always nice to have them. Shannon, we got about 10 minutes left to top the hour. Do you want to continue with some questions?
Absolutely.
Yeah,
Sandra,
perfect.
do you want to ask your follow-up question?
That would be fantastic with the pH. So I was wondering about the execution in construction with all these new details, and it's really a high level of airtightness that you achieved. I find that, part of the problem is getting trades to do things differently and that whole change management and training process. So how did you handle that?
Yeah, it was really a fanatical, meticulous attention to detail throughout. We would have liked to have gone into construction having someone, other than just myself with the trades training. Our general contractor did get through the EMU program partway through, so that really helped to have more of us out there. The Tanner guys were both certified. That helped tremendously. Our associate architect got her CPHD midstream as well. So this way the knowledge level ratcheted up as we went through the process.
I think that the basic though is that I think all the trades that we had there were good craftsmen. I mean, there were people that were very proud of their craft, very careful in everything they did up till this point. And once they sort of saw what we were doing and had it explained to them what we were doing and why and the ramifications of keeping the air barrier and getting good joints and that kind of stuff, they got it and they appreciated it, and they took really, they just took pride in their craft. And it just was an extension of who they were to begin with. So I think it's kind of a fallacy that in small town, rural areas that you don't get good craftsmanship, because I think there are craftsmen there, and once they get a chance to express that, they dug into it.
Yeah, it was absolutely not a question of available skill. I mean, the skill abounds. It was just a matter of they hadn't been exposed to it. So once they were exposed to it, they all had good attitudes, which was crucial. It was really pretty easy. I mean, everyone had an open mind about it and wanted to succeed. And I couldn't have asked for a much better team.
What a great ending to a great question. And I think that's a lesson we can all take away. Our next question up is from Tom Phillips. Tom, would you like to unmute?
Oh, Heidi ho, good to see everybody. Yeah, just the usual question. I may have missed it about climate adaptation and resilience. Great project, but whenever I see these big windows and no exterior shading, I go, well, what's going to happen in 20 or 30 or 50 years and so on? And you have real good overheating numbers now, but terms of worst case and future climate. How did you assess that?
Well, the windows face due east, and so actually slightly north of east. And the cowlings that we designed were an attempt at doing some shading. Probably I mean, that's when you're dealing with a mid-block building like this, your options are kind of limited. And I suppose that if it becomes an issue in the future, you know, somebody in the future could put more shading on the front. I think we're pretty good. You know, we're pretty good as we are right now. Obviously, it models out well in PHPP, but it was one of those trade-offs, sort of aesthetic versus long-term performance. I mean, the one advantage of this building is being a mid-block. I mean, we have very little exterior skin. You know, so most of our exterior exposure is on the roof, and it's a white TPO that's well insulated and covered with solar panels. So
Reminds me of Daniel Pearl at University of Toronto for a project, elderly housing. They put in brackets so you could add shading easily later because they didn't have the budget to put it in at the time. So
yeah.
For future projects, that might be a nice kind of future ready addition. But anyway, thanks again for sharing that great project.
Sure, thank you.
And thanks for your question, Tom, and for making us all think ahead. If not us, who? If not now, when, right? And our next question up is from Melvin. Hi, Melvin. Welcome back.
Hello. Yes. 9 a.m. is quite challenging. But yeah, the question's about the air barrier. I'm just wondering what were the reasons to not have the main air barrier at the exterior at the front facade? And are there any concerns with occupants punching holes in the exposed interior air barrier?
I can jump on that one. So we did the air barrier. What you didn't see in this presentation was the rest of the air barriers on the inside face of the existing masonry walls, because the owner really wanted to keep the exposed brick. And so that allowed us the opportunity to insulate on the outside. So with our air barrier on the inside of the brick wall, we just made it that much easier to connect to that zip layer that you saw on the backside of the facade, which was actually quite mid-wall by the time it was all said and done. We got a layer of rigid block wool over that, and then a service cavity beyond that. So that was probably 7 inches deep into the wall by the time it was finished. So really no concerns with anything going through that on the front.
As far as on the sides, I mean, yeah, the air barrier is kind of exposed, but I don't think anybody really has a reason to go into the brick. Yeah, I think it's sort of going to be self-policing. Plus, you can repair it. You know, if the air barrier is exposed and it gets damaged, it's also exposed to be repaired.
We will say goodbye to some of you. If we want to continue on, we're going to have the final 15, which is, again, a blast of 15 minutes, wrapping up all the questions and tying the rest of the day in so we can get back to work or our day or whatever has happened in your life. But thank you very much for joining us. We, the co-hosts and the team here at the Accelerator, appreciate you guys and everyone jumping in and learning about it. And please, as Kim said, invite your friends that are interested in Passive House to the 101 series next week. Mariana is one of the pros in our industry, and I look forward to it because, again, sometimes you just learn new language, because if you are a pro or a Passive House enthusiast, it's always nice to learn ways that we can share and educate our peers so we can grow this community. So thank you for joining us. We appreciate it all. Let's continue to build better. And from all the co-hosts and the team here, thank you very much. And Shannon, let's continue on in the final 15.
Perfect. The final 15. I know. I feel like I'm on like the urgent round now. So I think it's also worth mentioning that I think Gary is going to present Six&Kane in Germany. Is that right, Gary?
Yeah, that's right. I'm going to do it virtually because it's one of the 15-minute workshop rounds. It's a session Saturday morning on I think it's session 12, having to do with international retrofits.
Congratulations. I can't think of a better project because retrofits are hard enough without going for passive house certification. And the targets that you guys set and then exceeded on this one, it's totally worth a share, no matter what country you're coming in from. So Sarah Byer has a question too. Sarah, you want to come on?
Thank you. Yes, great project, amazing project. I have a question that I struggle with, which is the liquid air barriers on masonry backup walls. When you attach a bunch of screws through there for your cladding attachments, how do you feel about the durability of the air sealing properties once you penetrate it with a screw? I know, there's established understanding that it's still airtight, and obviously you'll pass the blower door. But do you have concerns about that? Have you done extra research for maybe on how that really works? Yeah, and if they make a mistake and they pull one out, do you ask them to seal it again?
I guess from my perspective, I thought about it early on, sort of read up on it, and yeah, I guess it's kind of faith-based that we're okay. I think that both the cladding systems have a have a thermal isolator pad that goes back against the surface, and I feel that the seal around that to the sealed surface, plus just the screw filling the hole, takes care of it. And on the back wall, being a 3-wythe masonry, and having the air barrier on the inside, I felt like we were kind of okay with that, because we're really on the backside. We're just going through the weather barrier. We're not going through the air barrier. Same on the front side. We're going through the weather barrier into the structure, not into the air barrier. So the air barrier is still inside.
Thank you. I'm sure there'll be many scenarios where that is the only air barrier.
Right. Yeah. I think if it were the only air barrier, I'd probably be a little more concerned about it. Or if we didn't have such massive masonry. Yeah.
Mm-hmm. I think the Air Barrier Association, there's like a North American one, and I think they are doing more testing and more research into this kind of thing.
I've done a little bit of reading on that. Yes.
Thanks, Sarah. And Rob Hoskin is here with us, the photographer extraordinaire. Rob, would you like to unmute and ask your question?
Yeah. Hi, everybody. I was just wondering if you could talk a little bit about air sealing of the other surfaces of the building, the party walls, and transitions between party walls and the facades, because I thought that was an interesting part of the project.
Thanks, Rob. Good to see you. We had relatively few places like that. Primarily, it was the party walls to the first floor deck, which was our air barrier. That was one part cutting the floor decking really close to the masonry, so that we had a small joint that could be easily taped and coated with Viscon. From the party wall to the back side of the facade, again, just good carpentry, making a small joint where we could tape brick to zip sheathing and coat with Viscon. There's some places that weren't that good. We just had to use some sealant, like the acoustic sealant type products, the thickened Viscon. And then top of the wall to the roof framing, again, just tape and Viscon.
Yeah, I think you also had your joist pockets. You pointed and around the joist pockets, and then we also have the 7. I think it's 7 steel beams that span party wall to party wall on the roof, and you air sealed around those. I mean, the way they built this building, they actually set the joists and set the beams as they built the wall. So they actually, rather than build pockets and then come back in and add it, they set the brick was tight up against most of the wood and the steel, as we looked at it. So it was really just a matter of getting in there and getting those walls cleaned up and pointed, and then sealed with the Viscon fiber. Similarly, I should note on the beams, since the neighboring roofs kind of dip below the line of the beams, we actually had to take a couple of thermal bridge hits where the steel beams go out into the party wall, where the other side of the wall is actually to ambient rather than to the adiabatic. So Tad kind of caught me on that one, and we had to go back and take another look at it. So we picked up a few thermal bridges there, but again, we had a lot of negatives because of the way we detailed the roof. That we ended up with a lot of outside corner to pick up negative bridges.
Yeah, if you go back and look at the presentation that we did on the Accelerator back in September of 21, we talked quite a bit about the ceiling around all the floor joists. And I think there were, I don't know, 600, I think, penetrations that we had to seal around. And we checked them all.
Yeah.
So
obviously, you get a point too. But we did have the mass masonry on our side too. I mean, one thing I did check, I did a little research on sort of the air tightness of mass masonry, and it's not bad because you've got so many layers. And so if you have a crack or an opening on your outer skin, you've got 2 or 3 wides of brick, and the way that it's turned and laid up, especially old traditional multi-wide masonry where you do the soldier courses and the headers and so forth, tying it together without ties, you tend to get a fairly tight wall. It's actually we had that working for us. That's something Mike and Gui can probably speak to as well. But it was being old masonry helped.
I love the old masonry conversations. It makes me want to dive into when the repointing happened. Did you have any requirements for the mortar types based on how vapor open you wanted it to be? I don't know if that was even part of the conversation, but I get curious,
We did not give it a lot of thought, actually, on the vapor tightness.
Usually the old masons who are repointing know exactly.
Yeah, they basically used a lime mortar, so it's a soft mortar. Yeah.
Yeah. Well, I have a couple questions for you guys. Can you talk a little bit about the systems and also the verification and balancing process?
Sure. The mechanical systems, we have a Ventacity 3000 CFM single unit on the roof. It's operating at about 1,000 CFM at sort of normal occupancy. Boost modes goes up to 1,300, and that does our energy recovery ventilation. The heating and cooling is Fujitsu VRF system. Fujitsu and Ventacity talk to each other. They've got an agreement between the two companies where they share the control system, so that works really well. It's well integrated. And also with the Fujitsu, we found that they're at the time they had a little bit better numbers as far as cold weather, which is a concern here. And also our contractor was a little more familiar with it, although he was good with Mitsubishi as well. We just in the end we went with the Fujitsu. Other systems, our hot water is mostly point of use. We've got small point of use heaters in the restrooms. The restrooms are all kind of stacked and ganged, and we're able to pair them. So we have a small point of use water heater for every pair of back-to-back lavatories and in the kitchen sinks. We have a small coffee shop on the first floor. They've got some refrigerator loads. So we put in a heat pump water heater in the same room as the commercial refrigerators. So essentially we're taking heat off the refrigeration units, the rejected heat from refrigeration units, and turning it into hot water. And directly, without any ducting or anything, just kind of, in the space. Let's see, other systems. We have PV on the roof. It's LG bifacial units with the Enphase micro inverters and the Enphase Envoy monitoring system. Let's see, we saw the windows, saw the doors, front and back doors are Conair. just because we needed something that had an ADA threshold and UL panic hardware, and that's what we ended up with. So trying to think what. Oh, we have a regenerative elevator. Notice regenerative elevator. So that helped our loading out considerably. All LED lighting, obviously.
Thank you so much, because I know a lot of people, when they want to learn about a project, they also want to understand how everything went together and where it came from. Now, when you did the balancing of the ventilation systems, did you have any challenges there after your modeled versus balancing?
No, ventilation was pretty easy to balance. It was well designed, well engineered. Ventasti helped out our engineer, Mike Norris, with it, since he was a little, a very experienced engineer, very attuned to what we were doing, just hadn't done passive house before. So, they were real helpful. The balancing contractor came through, and it really balanced up quite readily. We had a few issues with the Ventasti, not with the operation of it. Just they ended up with a few refrigerant leaks or refrigerant mysteries, but they chased those down quickly and got it resolved. So no, really no surprises on the HVAC at all, really.
Great to hear. And I love that you've got systems that are talking to each other and working in tandem. Beautiful. Well, I don't think I missed any other questions. If I did, you're welcome to unmute and jump in and let me know, because we have 1 full minute left before we thank everyone and remind you all to share this presentation as soon as it's up on the Passive House Accelerator Live website. And please thank Norm and Gary for an amazing presentation today in the chat, on LinkedIn, on their websites, and come back and see us in another couple of weeks.